Hello and welcome to this lecture of querying with Transact SQL. And this in this part, what we will do is we will use to combine multiple tables with joins using T-SQL. So basically, what happens is that uh, a normalized relational database contains multiple tables, and that is linked by the common fields. And this design minimize the duplication of data. But this means that you need to use and write queries to retrieve related data from two or more tables. So this means, for example, there is one table and orders table with the customer table, and we are combining, and we need to fetch customer details from the order table. So there will be customer ID in the order table, and customer ID will also be in the customer table, which is being joined to fetch customer name from the orders. So this is one example, but in this module we will be learning more on the concept of the join, as well as we will write queries related to inner join, outer join, cross join, and self joins. So basically the common join operations, along with the with the types of join that we will be using for. So let's get started. And as per the previous video, we will be using Azure Data Studio, and that we will be using AdventureWorks database. If you're following along, you can just use that as your database and download the AdventureWorks database in the series. So we will be using this one, and we will be starting off with the new query as per the we will be starting off with a new query and using the AdventureWorks database. So as per our previous lectures, we will just start off with the selecting all from the product tables. So let's go to the sales schema, and then go to product table. So we'll be using, so let's execute this, and this is the product table. And now what we'll use is we'll start off with using inner join. An inner join is used to find related data in two tables, and from that table, we will be using. For example, you need to retrieve data about, as it mentioned above previously, that we need to retrieve data about the product and its category. So we will be using product table as well as product category table, and then we will be trying to connect that table with the product category ID. So this is one product table. I'll copy paste, and then we'll see autocorrect. There is a product category table as well. So if I select and execute this one, it has product category ID as well as the details as well. And if you run this product table, there is a product category ID here as well. So we will be connecting this product table with the product category using this product category ID. So this is a foreign key here, and in this product category table, this is a primary key here. So we are connecting foreign key versus primary key. And then what we will do is we will use product table. So let's execute this one first. There are name fields in both product category and product category name. So what we'll do is we'll use this name as well, and in this one there's a product detail as well. Sorry, I made a mistake. And this is the product name. So this is the product name, and what I will do here is I will use product category ID here, and in this one we will use product category ID 2. So if we execute this one, it says against each product name there is a product category ID, and in that main category table we are using. So for example, previously it was A18, and it belongs to a this product category. Let me find where is 18. There it is, road frames. So the first product in the product table contains it belong to a road frames ID. But now we need to merge those tables together. What we will do is we will use this first table and then use the keyword inner join and this product category. Okay, and then once we specify this, we will be using a key to match up. So what we will use is we'll use the on keyword, and then what we will use is we'll just copy this dot product category ID, and then we will copy this another table and put an equal sign, and then sorry, not name, product category ID. So what it's doing is that so let me separate this out. What it's doing is it's connecting inner joins the product category ID on which field. First field is the category ID, and the second from the product table, and the second field is product category from the product category table. So we are just joining two categories. Now there will be some errors that will come up, and it will say ambiguous column name, because we need to put up a complete details about which table it belongs to. And this one, for example, this one belongs to this product table. While if I'll copy paste and use this sales product category ID table here as a product category ID, so this will fetch up another, and I'm fetching the product category dot name table name column from this. So now when I'll execute this query, it will have the product name, the category ID from product table, the product category ID from product category table, and the name from that product category table. So you've got a query and an inner join that specifies that what is how they are related, and what they are connecting. So by definition, what it says is that for each row in table A, which means this one is category, the inner join clause finds the matching row of table. So this means that regardless of the category, it is matching up with the table in the table B. So if the row is matched, it is included in the final result, and if it does not match, then it will not be included in the final result. One more thing to shrink this whole um, syntax and to make it an ease, what I will do is I will recreate this query with a shortcut aliases of the table. So for example, this is sales product, and this is a product detail about it, and I'm fetching, I need to give an alias, a table alias to the column, so that I can directly reference that table. So this is let me give in prod, or maybe give p. Let's give pd for the sake of it. Sorry, I'm giving pd here. And now what I can do is I'll use the same thing, inner join, and let's give this an alias of pc. Okay, and now what I can do is I can copy this. Once I copy this, I will use, instead of the whole line of schema name and product name, I can use pd as an alias with the column name, and in this case, yes, that's true. So we'll use PC as a product category ID, and in this way, we are easier. We feel much more easier to um, define the column name. So, for example, PD dot name. This is from product. Then PD dot product category ID. Then PC dot product category ID, and then PC dot name. So now the results would first I'll run this query. So if you see here, this is the records they'll be showing 295 records. And in this ways, if I use table alias, it will also show the same results as it is, but it will be a much more precise, or smaller query to be used here. As I mentioned earlier, the use of inner join means that any product that do not have a corresponding category, and any categories that contain no product, are omitted from this result. So for example, this product, there's no category assigned to this. They will not be present here. Similar, likewise, if there is no category associated with the product category mentioned, it will not be included. So if we remove, there is one more trick. If we just use a join keyword and then execute this, it will return the same result, because what happened is that SQL by default uses inner join as a default kind of a join. So we'll try one more example, and I will just use the order header and order detail and related product associated with it. So this means that we are combining two or more tables, maybe three tables in that. So what we'll do is we'll start off with the same. We'll use select all from sales lt dot sales order header, and we just give an alias as order header. So if I try to execute this, it will be executed. So it is sales order ID, and all the details about that is given here. What I will use is, I will use join sales lt dot order detail. So sales order detail header we've already included, and this will keep we'll give this as a od, and we have to specify, sorry, od, and then we have to specify on. And now what we'll do is we'll oh dot sales order id equals od dot sales order id. If we'll execute this, it will be executed, means that the join is working, but we need to include the relevant columns to that. But before doing that, we will use another join to join product table, sales lt dot products, not product category, and we'll assign this as p, and this is on. Then we will use is order detail dot p, sorry, order detail dot product id equals p dot product id. So this is working, and we will just try to execute this to see the query is working. This means that join is working, but we need to include now the columns, because it is just taking the all the columns from sales order header, not following along with the details. So we'll just need order date, and then order number, oh dot order number. This is sales order number, and then p dot name. This is the product name, and order detail dot order quantity, and order detail dot unit price, and order detail will have line total as well, and we will also include oh dot total total. Now let's try to execute this, and it will have a combined query related to order date, sales order number, name, order quantity, unit price, line total, and total due. So this is total due is coming from the order header table, and the total line total is coming from the order detail table, while the product name is coming from the product table. We will also include, we can also include, for example, um, standard cost. Make sure to have add comma to that, and then we will try to execute this. So it will include the standard cost of that product as well. So this means that we are able to run inner join and join the table related to order details as well as the product category. So basically the syntax is simple. Whatever you're using, you are using the first table A, and then join based on the keys, and include those columns in the column aliases as well. One more thing, as per the inner join, it is only checking the matched rows, so there will not be any nulls associated in this result set. Which means that it's omitting anything that is not present in the either of the table that is not matched. Now we have done with inner joins. We'll use outer join. An outer join is used to retrieve all rows from table A and any corresponding row records from the related table. So in case where the row in outer table has no corresponding row, it will relate to a null value entered in the mentioned in the field. So for example, now what we'll do is we'll just use this customer and order header table to fetch information. So for example, now what we'll use is we'll use the customer table, and sales lt dot customer. So we'll just assign them as C, and then execute this. So this is customer information. But now what we'll do is we'll use the we need to fetch the any customer that has orders, that has placed order. And now what we'll use is we'll use left outer join. I will explain these type of join in later on with the details. So we'll use sales order header, and in this says we'll use that and specify on c dot customer id equals dot customer id, and we'll use another clause called order by, as we'll use order by c dot customer id. So let's execute this. We are using only customer details, so it will come up as a customer detail. But now what we'll use is we'll use the c dot first name, c dot last name, c dot order, sorry, oh dot order number. Okay, let's include order date as well. Oh dot order number. So I'm using this one from sales customer id. And then what we're using, it's showing as first name, last name, order date, sales order number. So it's showing as null. So these customers don't have order, but there will be some customers which have the order as well as the order number as well. So this means that if a customer has placed an order, the order number and the order date is shown, and the customer who has registered but not placed the order, it will come up as a null order number. So remember, we are using left keyword. This identify that which table in the join is an outer table. So this means that the one from which all rows should be preserved. So this means we are looking for customer customer as an outer table and include all rows regardless of the values related to a customer, or sorry, or order or not. If we use right outer join, then see what happens. So now it is using order table as an outer table and customer details as a other as a different as a table that only fetches up the records. So it's basically returning all the records from sales order header table and only matching data from the customer table. So we can play around. We can, we can use sales order as an outer table and then, use the left outer join. Generally, it is the best practice or general practice is that, we use the left table. We use generally left outer join. And if you want to if you want to see the similar result, we'll place this order header and as a first table, and then left outer join as a on the customer table as a as after the left outer join keyword. There is also one more keyword that is used, which is called full outer join. This means that it will preserve both the table information. So we can see nulls here as well as in the order header table as well. So full outer join, it is running and it is including the null column here as well, and we are checking that there will be null as well here in the customer details as well. But this is not possible because for each placement of the order, the customer has to be registered. So this doesn't work in but if we want to figure out as a query or as a data quality thing, we need to find out all the orders of the customers placed, or vice versa. We can use full outer join as well, which is basically in practice was used less frequently. Now we are using, if you scroll and we're using, for example, let me go back to this left outer join and generate a query here. So if you see here, we are using three keywords: left, outer, join. If we use join, this means that it is an inner join. But if we use left, outer join, there's another keyword that is in between left join or left outer join, is the outer keyword. Now we'll figure out, if we remove outer from this query, what will happen. Nothing happened. So it is using um, it is an inbuilt outer in the query language. If we don't use outer join, this means that it is by default included, so that doesn't matter in terms of if we use left or right keyword, the SQL engine automatically identifies whether it's an outer it is an outer join. But now the table is left outer or right outer. That is the thing. So now comes, now we've got something, and now we need to figure out that who are those customer who have not placed order. So now it's just a simple where clause where oh dot sales order number is null. So this means if we execute this, so this will be returning the fact that these are the customers which haven't placed any order. We can use not keyword as well, and we can see how it works. So it is all the customer that have placed order. So we'll keep this as it is, and we'll see how it executes, and it will just display null values related to that. Now we'll copy this query, and we will use any query that is specified as we're using multiple tables, and we can also use outer join as well as inner joins together. So what we will do is, we'll, instead of copying this query, let's start off with a fresh query. So we'll use product table. So this is a product table, and then we'll use left join order details, od on p dot product id equals od dot product id, and then we'll use another join, left join sales lt dot sales order header on, say, sorry, let's do it oh, and then we'll use od dot sales order id equals oh dot sales order id. This is executing with the product, and now we will use, we've used outer join, but now we'll use inner join category. Now we'll use c on product, sorry, p dot product category id, p dot product category id equals c dot product category id, and then we'll use order by, sorry, order by p dot product id. So this is the query that is ready. Now we need to specify the columns that we need. So we will be using p dot product name, c dot product category name, comma, and then oh dot sales order number. So this is saying product name as well as the category name as well as the sales order number. So all product associated with. The reason why I'm using sales category or product category and the product ID as an inner join, because we just need matching rows associated with it. So this is showing as product name, product category name as well as sales order number. So basically, inner join and outer join are the two most frequently used in SQL, but there are other joins as well, like cross join as well as self join. A cross join only matches up all the possible combination of the rows from table being joined. So in practice, it is rarely used, but in some specialized cases, it is useful. So practically, for example, if you want to use if you are using an email campaign of sending all the customers, all the products are in with active products, which means that we need to generate a query that use cross join or a Cartesian product or a combination of product. So I'll scroll back up, and if I see here this product, sorry, let's write another query, new one. So we're using select all from sales lt dot product and cross join customers. In cross-join, we don't need to use on, so we can just directly use, sorry, yeah, we can use just product name, um, customer first name, c dot last name, c dot email address, and there you go. You're running a product name for all customers. This product name is executed, and that email address is coming from this one product for all customers. So the combination is around 250,000 records that comes in. So this is basically cross join. Another category is self join. A self join is not actually a specific kind of join, but it is a technique that is being used to join a table by itself. So by defining two incidents of the table, like each product category joins with the product category as well to match up the subcategory, for example. So this approach can be useful when a row of the table includes a foreign key field that is referenced the primary key in the same table. So employee, manager, product, subproduct category, chart of accounts, for example, the top header account, as well as sub accounts and stuff. So this can be used or connected through self join. So I might use the product category table and fetch up the product subcategory associated with that. So we'll use select star from sales dot, sorry, sales lt dot product category, and we'll specify that as category join sales product category p category is scat. Let's do it. So scat on cat dot product category id equals scat dot product category id and order by pcat, sorry, scat dot name and cat dot name. So we'll include this in our results. So this is saying category, subcategory connected within the same table that specifies a self join. So now we need to practice some things and some identify some real world problems to answer this. So for example, we need to retrieve customer orders. So as you can see, we've done it before. We'll use select all from sales lt, sorry, sales lt dot customers, and then execute this. So this will give me customer detail, but we need to find out customer order. So we'll just give a specify here join sales lt dot customer sales order header and oh on oh dot customer id equals c dot customer id. So what is doing it is just, so we specify c dot company name comma oh dot sales order id and oh dot total amount due. So we're saying company name by the sales order ID and the total amount due. So this is giving company names and sales order ID and just joining this. We can also tweak some information like retrieve all the customers who have placed the order, but they don't have the order customer address. So what we will do is we'll just join this query as the customer address. So giving a list of customers with the orders who have a customer address ID as null. So currently there's no customer associated where it says that it should be null with the order. So we've all placed it here, but let me try an option whether regardless of the order, if we use customer and remove the order details from this, and then this is retrieving all the company name of those customer where there is no address there. So if we see here c dot, sorry, comma c dot address, sorry, ca dot address. I'm executing this. So this is C, address ID is null. So these are the customers which are not, which haven't provided anything related to a customer ID. So these are some of the tweaks that we can do. We can use a where clause, we can use joins, left joins, multiple joins as well to figure out the multiple tables in the query. So in this video, I've gone through the type of joins that we've used in SQL, practically used inner join, outer join, and cross join and self join as well. And we've used some of the queries to enable some of the handle some of the use cases associated with a customer and an order related stuff. If you're watching me for the first time, please don't hesitate to subscribe and like. Also, I would appreciate if you'll provide your feedback so that I can improve. Thank you so much.